Hello friends, in this video we are going to revise the thermodynamics what we have learned in last 19 videos. Okay, so the basics of the thermodynamics we understand, but you have to revise what you understand first of all. So I will touch all these points very fast, maybe very fast, but you have to go for details in each of them videos where I have explained the details of the points. Okay, now first what we have seen, that is the thermodynamics. What do you mean by thermodynamics? It is the branch of physics which deals with the study of conversion of the thermal energy into dynamics. Okay, so thermal energy is converted into kinetic energy, mechanical energy, any one type of an energy, and the interconversion, once again, some kinetic energy may convert into heat, may convert into thermal energy. So that means vice versa. So one type of energy, that is heat energy, kinetic energy, thermal energy, converted into another type of energy is converted into, that is cell. So that branch we are going to study how that conversion taking place in different, that is the systems, different the states, etc. So for that, to study the thermodynamics, we have to define one, that is the parameter, that is known as the system. What is system? Whatever in the universe is made up of large number of materials. So each material consisting in large number of molecules. You all know atoms and molecules. So the universe which consists large number of materials. Say this is the pen. This is the material. This is one of the thermodynamic system. May behaves as a thermodynamic system. If that exchanges the energy with respect to surrounding or with respect to another, then it behaves as a system. Any bottle you may take, water bottle, that is also becomes a system. So whatever it may be you consider, then the system is a part of the universe under this study, where we can study how much amount of energy that has been exchanged but with respect to surrounding, and already once again taken and that is given out. So what is the system? System is the isolated part of the surrounding. Isolated, that is separated part of the surrounding. Isolated part of surrounding or nature, where we can study the heat exchange. Then what is surrounding? Surrounding is the nothing but the remaining part of the that is the system. Remaining part of the that is the, when you consider a system, this is a system. Then that is the surrounding of this system is called as a surrounding. So if myself behaves as a system, then this room may act as a surrounding, where I can exchange my energy, because when the room is heated, I becomes very hot. When room is cooled by using AC, I become myself feeling cold. That means you have, that is some sort of exchange of heat, exchange of energy, that is noted as surrounding. So surrounding is the outside part of system, outside part of system. So you understand this. Then surrounding and systems are separated by each other by using, that is known as boundary. So boundary which separates the surrounding and system. So if you consider the any one system, like say we have considered already the simplest model, that is the gas model. So this cylinder consists large number of gas molecules. These molecules now behaves as a system, and the remaining part of this, that is the gas cylinder, is behaves as a surrounding, and this, that is the boundary, which is made up of either any one metal or any, that is the plastic, this behaves as a boundary. So already we know there are two types of the boundaries. One, it is called as, yes, diathermic boundary, and adiabatic boundary. So diathermic boundary, which exchanges the heat energy with respect to surrounding, and adiabatic boundary, which do not exchange the, that is the heat energy with respect to the other. So that means if this boundary is a diathermic, that is metal, then the amount of large amount of energy inside the system, then it goes to the outside. If some heat is extra in the surrounding, then that heat goes to the surrounding system. So that means there is exchange of heat energy with respect to, that is the surrounding and system, by using diathermic boundary. But if you consider the boundary is adiabatic, there is no exchange of heat energy. So this is the one part what we are seeing, first part, that is introductory part, where the thermodynamics is the study of the branch of physics where we deal with the interconversion of heat energy into thermodynamics, dynamics. And to study, we are going to consider one system. That system may be engine, that system may be, that is the anything which is able to exchange the heat energy. So system we know that, surrounding we know that, boundary we know that. There are two types of boundaries, also we know that. Then, now we are going to consider the systems, the state of the system. State of the system. What is the difference between state and system? So you all know that system remains same, but state of the system may change. That means what? If we consider a system, this is system, bounded by some diathermic boundary or adiabatic boundary, whatever you may call. But this boundary is made up of, that is having some pressure P, temperature T, and volume V. These, that is pressure, volume, and temperature, that is the bounds or forms the system. When system forms, then system has particular state at particular time. If the system has the variables P, V, T, then this is called, these variables are called as the variables of states. So these are also called as the variables of state, are also called as the thermodynamic variables. If one variable changes, automatically other variables may change or sometimes may not be changed. So the variables which we are used to define this state, then the variables are called as thermodynamic variables. And these variables are used to define this state. So this is the state. What we suppose that A state, the A state having pressure P, temperature T, and volume V. Isn't it? So A is a state. If anyone can change, that means pressure is changed, then state A goes to state B. But system remains. So that means when one state variable changes, then state of the system changes, and when state of the system changes, but does not mean that system changes. So its engine performs the different types of the states. Engine performs it converts the one type of energy into another type of energy. But the state of that or system of that engine remains same. Isn't it? So this is the variables and state of the system. Then we are going to consider the thermodynamic equilibriums. So what is equilibrium? If we consider this is a thermodynamic state. This is a thermodynamic state having pressure P1, temperature T1, volume V1. Then this thermodynamic state or system consists the large number of gas molecules. Suppose these are all from air. That is air. This gas cylinder consists of air. Some part of this that is the air. So this air has having pressure P, temperature T, volume V. If surrounding, that means outside part of this system, is also having pressure T, temperature T, volume V. That means inside pressure, volume and temperature, and outside pressure, volume, temperature and other quantities are same. Then these two system and surrounding are said to be thermodynamic equilibrium. You understand? So if pressure is that is the same, then that is called as mechanical equilibrium. So there are three types of equilibrium. Mechanical equilibrium. We have already discussed these points. So one part is mechanical equilibrium. That is pressure or mechanical energy inside the system and outside the system are same, then this is called as mechanical equilibrium. If temperature remains same, there is temperature of the outside and inside remains same, that means it is called as thermal equilibrium with respect to surrounding. And third one that is chemical equilibrium. Chemical equilibrium where the composition of air inside this cylinder and outside this cylinder are same. That means the air contains some part of oxygen, carbon dioxide, different types of the gases, nitrogen, etc. The same amount of the air is consisting in this. That is nothing but the chemical, that is the equilibrium with respect to surrounding. So we have seen the thermodynamics, system, surrounding, boundary. There are two types of boundary: state of the system, variables of the system, and then the thermodynamic equilibrium. There are three types of the thermodynamic equilibrium: mechanical equilibrium, temperature, that is thermal equilibrium, and chemical equilibrium. Okay. Then we are going to see the next point, that is known as first law, that is the zeroth law of thermodynamics. Zeroth law of thermodynamics. So what is zeroth law of thermodynamics? If we consider the three systems, A system, B system and C system. If A is in thermal equilibrium with respect to, that is C, B is also in thermal equilibrium with respect to C, then automatically B and A are in thermal equilibrium with respect to each other. So this is known as the zeroth law of thermodynamics. Okay, so this video only is a part of revision where you can conclude the different points of thermodynamics, where we can better understand, once again understand what is thermodynamics, what is system, what is surrounding, what are the types of the boundaries, how that boundary exchanges the heat energy, then state of the system, variables of the system, different equilibriums of the system, and zeroth law of thermodynamics. Okay, in next video we can observe some other points. Thank you.